Okay, good evening and namaste to all the students. It's me Bidur Ariel. As usual, I am present in front of you all to solve a numerical of the specific heat capacity. So here's the question. Three liquids A, B and C having equal masses are kept in sunlight for 10 minutes. Three liquids A, B and C are kept, they have got equal masses and they are kept in the sunlight for 10 minutes, and the rise in the temperature in those three liquids A, B and C is given there in the table. Okay, A 10 degree, B 8 degree and C 6 degree centigrade. Now the question is, which liquid has highest specific heat capacity and why? Which of the following liquids will have the highest specific heat capacity and why? So for this, okay, we have to do like this. If like these questions are asked in exam, then you must not forget the heat equation. Q is equals to ms dt. This is our heat equation, like this equation. So as mentioned in the question over there, equal masses are kept in sunlight for 10 minutes means mass is same. Okay, of all three A, B and C liquids, mass is same, and they are kept in the sunlight for 10 minutes means they are being exposed to the sunlight for 10 minutes. That means same amount of heat is being supplied to the three liquid A, B and C having equal mass. So let us underline over here, and we don't need to consider this heat and mass. Why? Because it is equal. It is equal, so we don't have to consider this Q and M. Now our equation becomes 1 equals to 1 into S dt. Okay, and now from the question, which one has got the highest specific heat capacity? Okay, which one has got the highest specific heat capacity? Or S is inversely proportional to the temperature difference or the rise in temperature. Now from here, since the relation is inverse, okay, specific heat capacity is inversely related to the temperature. So highest specific heat capacity, which one will have the highest specific heat capacity? Now look over here. So the substance which has got the lowest temperature, the substance having the lowest temperature will have the highest specific heat capacity. Now let's look at the table over here. Substance A 10, it is higher. B, yes, it is 8, it is higher. Then C has got the lowest temperature. Lowest temperature, substance C has got the lowest temperature, and it will have the highest specific heat capacity. We all know that the substance having lowest specific heat capacity will absorb the heat very fast and it will increase the temperature very fast. Like we all know that the deserts are very cold during the night time and very hot during the daytime. Because why? Because the specific heat capacity of the sand in the desert is less, so the rise in temperature will be more during the daytime. And like as we have already studied that, yes, water, the specific heat capacity of water is 4200 joule per kg per degree centigrade. Okay? So for water it takes a lot of time to be heated and it takes a long time to cool down. So the substance which has got highest specific heat capacity will have the lowest temperature, and the substance which will have the lowest specific heat capacity will have the highest temperature. Okay, highest temperature, highest specific heat capacity over here, the substance C, and the lowest specific capacity, which substance has got the highest temperature? So substance A over here. Okay, so this is very important from the examination point of view. Okay, thank you dear students, thank you.